So we're here in Warren, New Jersey. We're working on a new home, and this is going to be a highly efficient home, and we're taking advantage of heat pump technology.
What makes this a highly efficient home?
So there's very efficient insulation, window, roofing materials, and pretty much everything about this home is meant to minimize energy usage. All the penetrations have details for sealing, and all the windows are sealed properly, and that's going to really lower the energy consumption.
How about HVAC?
So the HVAC here is highly efficient Mitsubishi heat pumps that will do heating and cooling for the home.
How many total zones do we have here?
We have a total of 6 zones for this house.
How many ducted?
5 ducted zones.
And a ductless zone.
And a ductless zone.
What's the ductless zone doing?
The ductless zone is just doing the mudroom space, the garage entry space. It's a completely different environment, so it makes sense for it to be on its own zone. So this client was very concerned about indoor air quality. We have 3 Zender ERV systems, and in addition to that, we also have 3 humidification systems and 2 dehumidification systems, and also a whole makeup air system for the home to make sure that we're always bringing in fresh air.
Right here, this is an interior ceiling. That's not an exterior roof, so even everywhere it's being insulated. High-end homes aren't just installed, they're engineered. These projects involve multiple comfort systems that must be designed, coordinated for all of it to work together. And at this level, success is all in the details: planning, execution, oversight. That's why homes like this require true project management and specialized expertise, not just installers, not just your average company. Yeah.
Supply duct, right? And then we have ERV, intake and exhaust. So we're going to have our unit's going to be here in the corner. Our ERV is going to be here wall mounted. Our makeup air system or humidifier is going to be down here. We're going to have a lot of equipment all in this room.
A pretty busy room.
Very busy.
Yeah. Where's the Zender ERV going to be? Right here?
Right here, wall mounted.
No, the Zender ERVs are pretty big.
Very big. Below it, I believe we're placing the dehumidifier, and I think our makeup air system is wall mounted over here. Here we see those 2 gray hoses, and that's leading to that box with the red cap right now. The red cap will be removed, and there will be a round outlet. This is part of the Zender ERV system. This is what's going to bring in outside air into this home and exhaust stale air from this home while recovering the energy.
All right, so I noticed there's 2 flexes there. So this is both supplying and exhausting? What's it doing exactly?
It's both supplying. Each flex can only carry 15 or 20 CFM, so we're trying to achieve more than that. And Zender has boxes with 2, 3, 4, 5 connections that are even
Okay,
possible.
that makes sense, because I see some of them that only have 1 supply and some will have 2, so that's just more air into the spot.
Based on design, yep.
So we are back much later after 95% completion, and we're going to check in on the project and see what exactly came of it. So explain to me, why are these units raised?
So these are hyperheat units. They may be relied on during the winter for the primary heating for the home. So we want to raise them to account for snow buildup. We do not want the snow blocking the fan, blocking the electronics, and damaging the equipment. When these units operate in heat pump mode in cold conditions, they will build frost on the coils. The units do come in defrost mode, so at periods of time, they will warm up and you will have some melt, some water coming off the bottom here. So in very cold conditions, this melt will refreeze and it can dam back up. If that ice gets into these coils, it will ruin the equipment. It's very important to have this elevated.
Here's something we don't see all the time. What's going on at the wall penetrations over there? What is all that?
So this client was very concerned about any kind of water infiltration into the home. And piping wiring penetrations tends to be one of those items that does allow water to get into the home. So we isolated each line and each wire with an AirX penetration terminal.
Yeah, and what I see that's different is that a lot of multi-zone systems, people might use that, but they actually bring out the whole bunch of lines all at one penetration. We actually have each zone coming out at each separate as a separate penetration.
Just an extra precaution to make sure we have a good seal around each line and each wire, rather than having 2 or 3 pipes in the same penetration, which is harder to make a seal around. So a piece of equipment like this has a lot of highly sensitive electronics. With various power fluctuations, we want to make sure if there's a surge that we protect the equipment. This is very important to install in any kind of inverter-driven equipment with sensitive electronics.
Yeah, right above our units here, I see this big, huge wall cap, but it actually looks a little bit too big just to be a wall cap. So what is that exactly?
That is actually a kitchen exhaust fan. This client is sensitive to noise, so we removed the noisiest part of the kitchen exhaust to the outside. You push a button on the hood and this fan activates.
So the actual motor is located right here, not inside.
Exactly.
Makes it quiet, right?
Makes it quiet. Here we have a secondary kitchen for the home. Some people call it a summer kitchen. We have a kitchen exhaust hood, which is turned on by a switch, and it has a speed control. And automatically interlocked with this is the makeup air systems. This home is very tight, so as we're exhausting air out, we're bringing air back in. And that's done with this grill here that brings outside air in, and it's treated with a special makeup air system that I can show you next. So here we are in the second mechanical room on this lower level. It's housing this complete makeup air system. That larger box that you see, that has the fan and the filter that brings in the outside air. As the air comes through to the home, it's tempered by this electric heater. And as you look a little down, that spiral looking expanded item, that is the silencer to minimize the noise that the homeowners will hear in their finished space.
So Lev, I've seen makeup air systems before, but this is a little bit more of an advanced one. Why don't you explain what exactly it's doing and how it's sequenced with the kitchen exhaust fan?
So this system has control wiring out to the exterior mounted exhaust fan. We have a current sensing relay out there that picks up how much amperage is the exhaust fan drawing. So depending on what fan speed the fan is on, it's either 3 amps or less, and this will ramp up and ramp down according to that input.
That makes perfect sense. This is why I hear this unit get louder or quieter. It's actually working in accordance with the kitchen exhaust fan.
Exactly.
I recognize everything in here, Lev. We've got a boiler system. We've got some water filtration. I know this is a dehumidifier. Of course, we have our Mitsubishi ducted air handling system. But this big white box, this is not something you find on every job site. Explain to me exactly what this is.
This is a Zender ERV, energy recovery ventilator. We have 2 sets of ducts. One that goes and brings air in from the outside and also exhausts air back to the outside. And the second set of ducts is exhaust from the home and supply air back into the home. So what this does is, as we're exhausting air from the home, we don't lose all the energy. We recover the energy through the cross filter that's part of this machine, and then return it back into the home.
All right, so how exactly are we delivering that air into the home?
So this system is completely independent. It is not connected to other mechanical systems. It has a distribution network of small 2 or 3 inch flex tubes that connect to various points in the home. Bathrooms, kitchens, laundry rooms, to exhaust air out, and then also to bring fresh air back in.
So I know we got the whole house dehumidifier. It's one of a couple of units in here, right? But normally, a lot of times what we do is we'll connect a dehumidifier back into the distribution network of a ducted air handling system. But here, what are we doing here, Lev?
So we have an independent duct system for this as well. This is the supply air back into the home after it's come through the machine and been dehumidified. So we're using this room as a plenum return for this machine. There's a means of air coming back into this room from the basement area of the home, passing through the machine, getting dehumidified, and then getting returned back into the home.
So I'm looking around this ceiling, I see a bunch of different grills or diffusers, and there's something over here, something over there. You talked about that already being the makeup air for the kitchen. Talk to me about what else we're seeing here in the ceiling.
So that larger grill there, that is the return for the system serving the space.
Makes sense.
The round grill, that part is the Zender ERV system.
So that's what's supplying fresh air into the space.
Correct. And you can see them in a few locations around the home. There's one in that back corner right there.
Right, so I kind of see them almost in every space. And these are a little bit different than your normal grills.
So those are the supply registers. This home has a modern feel, so the homeowner wanted something that looked a little more sleek and clean, and this is the selection that was made.
All right, but those are coming from the ducted heating and cooling system.
Correct.
So right here on the wall, I see 3 different sets of controls. We have this warm board. I assume that is the radiant floor heating.
Correct.
We have this nice, beautiful little controller. What is this?
That is for our Mitsubishi heat pump heating and cooling systems.
All right, and then the last one here?
That is the controller for the Zender ERV system.
All right, and they're all separated. I think I like that concept, not being integrated into one. It just gives you individual control over each individual one, and you don't have to have one on to get fresh air coming to the space, perhaps. So I think the reason the Zender design was here in this house is because we can get continuous fresh air coming in all the time from all these points where we have those diffusers, and a house can have continuous fresh air, so it's not stale and musty in here. As you can imagine, in a house like this, we are in here on a very cold day. The heat's not really on. It stays warm. There's no loss in heat in a house like this.
We don't have to rely on the heating and cooling supply ductwork to deliver the fresh air. It's all independent. So, very tall space, probably 30 plus feet. And you can see there's a large fan installed. It's probably made by a big ass fan brand. Without some mechanical circulation, the air will be very stagnant at the top of the home. So the fan will help circulate. Also, if you notice, we have some return grills at the top of the space. That's also going to help us with circulation. We're supplying down low and we're returning back at the highest point.
Exceptional homes deserve exceptional mechanical systems, designed, coordinated, and executed without compromise. If you are building with advanced HVAC, integrate comfort systems elevates comfort while lowering operating costs. This is high-end HVAC done right.